Hello everyone, welcome back to my channel. So in this video we will learn the formulae for gamma propagation constant. Okay, propagation constant, and formula for alpha, that is attenuation constant, and also beta, phase shift constant. Okay, so we'll learn the formulas for all the three constants in EM wave. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, we know that the wave equation in terms of electric field, so this concept I have already explained you in my previous video, right? So if you have not seen, please see that video. Okay, so I have derived there how the wave equation will be obtained in terms of electric field. So there we have got the result as del square E bar is equal to mu sigma dou E bar by dou t plus mu epsilon dou square E bar by dou t square. E bar by dou t square. So this is the wave equation in terms of electric field. So we need wave equation in harmonic form. Wave equation in harmonical form. Harmonical form means in frequency domain, right? In frequency form or frequency domain. So how can we convert this into frequency domain? So dou E bar by dou t can be written in frequency form as j omega E bar. That is applying this Fourier transform. Okay, so differentiation in time property of Fourier transform. Okay, so differentiation in time property of Fourier transform. Okay, so from this we will get like this. Similarly, dou square E bar by dou t square. So 2 times differentiated, so 2 times you have to write j omega. So j omega whole square into E bar. Okay, so I am substituting this value and this value in this equation, so to obtain the wave equation in harmonical form. So del square E bar is equal to mu sigma dou E bar by dou t can be replaced with j omega E bar. Okay, understood? So differentiation in time property, so d by dt of anything is equal to d. So differentiation in time property, what does it state? D x of t by dt is equal to j omega into x of omega. Similarly, dou E bar by dou t is equal to j omega into E bar. Okay, right? So this is the j omega E bar plus mu epsilon into j omega whole square into E bar. Okay, so if you take j omega mu as constant, j omega mu if you take constant, so j omega mu, so all these are taken outside, so it will be sigma plus, so 1 j omega mu is there, so we will left over with j omega epsilon, so j omega epsilon into E bar. Okay, so just take j omega mu common, j omega mu into E bar as common from both the terms, so you'll get like this. So this term is called as gamma square. This term is called as gamma square. So gamma square is called as propagation not gamma square. So gamma is called as propagation constant. Okay, I'll tell you what is propagation constant now. Okay, So del square E bar, so this term is gamma square. Del square E bar is equal to gamma square into E. So this is called as wave equation in harmonical form. Wave equation in harmonical form. In harmonical form, or it is also called Helmholtz equation. Helmholtz equation. Okay, right? So this is the gamma. So what is gamma here? Gamma is given by root of j omega mu into sigma plus j omega epsilon. J omega epsilon. So unit is per meter. Unit is per meter. Okay, so this is the formula for gamma value. Okay, so gamma is called as propagation constant. Okay, let me take one more slide. I'll explain you clearly what is gamma, alpha, beta. Okay, so next we'll see the physical significance. Physical significance of alpha, beta and gamma in wave propagation. Okay, in wave propagation, so what is the physical significance of alpha, beta and gamma? So when a wave is traveling, right? So when wave is traveling through any medium, okay, so when wave is traveling through any medium, it gets attenuated. It gets attenuated, right? It is the observed phenomenon. So when wave is traveling through any medium, it gets attenuated. What is attenuation? So electric field strength and magnetic field strength gets reduced. Okay, so it is not same, right? Electric field strength and magnetic field strength are not same during the propagation of electric field or electromagnetic field EM wave through any medium. Okay, so at the start it may have the maximum amplitude. So as wave is traveling, right, so wave travels for a certain distance, so it always gets attenuated. Okay, so this attenuation is with respect to amplitude, right? This attenuation is with respect to amplitude. Okay, so this amplitude attenuation amplitude is represented by alpha. So that is why alpha is called as attenuation constant. Alpha is called as attenuation constant because when a wave is traveling through any medium, it always gets attenuated. That is, electric field strength and magnetic field strength reduces. Okay, so that reduction is represented by the term alpha. Okay, so this is why we have used in wave equation also e power minus alpha z. We have used a term called e power minus alpha z. So e naught into e power minus alpha z. So that is, wave is getting attenuated, so amplitude is getting decreased. So amplitude is getting decreased. Okay, that is the physical significance of alpha. So its units are Nepper per meter or dB per meter. Its units are Nepper per meter or dB per meter. Okay, so 1 Nepper is equal to 8.686 dB. 1 Nepper is equal to 8.686 dB. Okay, similarly, when wave is traveling, right, so when wave is traveling through any medium, its phase also changes. Phase also changes. Okay, so phase also changes. So this change in phase is represented by beta, so which is called as phase shift constant. So that is why it is called as phase shift constant, right? Its units are radian per meter, right? Phase is radians per meter. Okay, so for every length it will change. So how many radians it is changing for how much distance is represented by phase shift constant. Okay, so this is the significance of alpha and beta, right? So gamma is the combination of both. Okay, so when a wave is propagating, so you'll have both attenuation constant and phase shift constant. So gamma is equal to alpha plus j beta. It is an complex term. It is a complex term. Okay, so gamma is equal to alpha plus j beta. Okay, so its units are per meter, right? So that is why this is called as propagation constant. So when wave is propagating, how the wave gets attenuated in amplitude and phase. Okay, so how it is attenuated in amplitude and how the phase shift is changed, so is represented by the term propagation, is represented by the term gamma. So that is why it is called as propagation constant. Okay, so when wave is propagating, so it represents the constant, so it is called as propagation constant, right? So now we have got the idea of what is alpha, what is beta, and what is gamma. So gamma is always equal to alpha plus j beta. It is always the combination of attenuation constant and phase shift constant. So real part alpha is real part of gamma, real part of real part of propagation constant is attenuation constant. Similarly, imaginary part of attenuation constant, propagation constant is phase shift constant. Okay, so imaginary part of gamma is beta, real part of gamma is alpha. Okay, so gamma is equal to alpha plus j beta. So this is equal to root of, so in terms of medium parameters, j omega mu into sigma plus j omega epsilon. Okay, so per meter. So we have the equation for gamma, but we don't have equations for alpha and beta in terms of medium parameters. Okay, in terms of these medium parameters, we don't have any equations. Okay, sigma, epsilon and mu are called as medium parameters, right? So this we already have discussed. Okay, so in my first video of waves, right? So in terms of medium parameters, we have formula for gamma, but we don't have the formula for alpha and j beta. So let me take one more slide and derive the equations for alpha and beta in terms of medium parameters. Okay. Okay, so just now we have got gamma is equal to alpha plus j beta, which is equal to root of j omega mu into sigma plus j omega epsilon. Okay, so taking these two, right? So squaring on both sides. Okay, squaring on both sides. So alpha plus j beta whole square is equal to j omega mu into sigma plus j omega epsilon. So this will be alpha square, a square is alpha square, b square is j beta whole square. So j beta whole square is minus beta square plus 2a beta, 2 into alpha into j beta. So it will be 2j alpha beta. Okay, so b square is j beta whole square, j beta whole square is j square beta square. So j square is minus 1, so I have taken minus 1 directly. So this will be equal to, so if you multiply these two, so j omega mu multiplied by j omega epsilon. So j into j is j square, right? J square is minus. Okay, so omega into omega is omega square mu epsilon, omega square mu epsilon plus j omega mu sigma. Okay, so equating real parts and imaginary parts, so we require only real part, of course, right? So if you equate real part, so what you'll get, alpha square minus beta square is equal to minus omega square mu epsilon. So let this be equation number 1. Okay, similarly 2 alpha beta, so if getting imaginary part, so it will be 2 alpha beta is equal to omega mu sigma. Let this be equation number 2. Okay, and again, so gamma is equal to alpha plus j beta. Okay, so I'll take gamma square. Okay, don't worry. So gamma square I'm taking. Okay, so not required. Let us take gamma only. So is equal to under root of, so if you multiply under root this one, so what will be this value? Minus omega square mu epsilon, right? So this value minus omega square mu epsilon plus j omega mu sigma, j omega mu sigma. Okay, so modulus gamma value, so it will be modulus of alpha plus j beta. Okay, so if you take square here, then you can take square here. Okay, so what does this value become? So this is also modulus of minus omega square mu epsilon plus j omega mu sigma modulus. So we have taken square, so I am taking square here also. So if you take modulus here, so and squaring, so modulus here and squaring, modulus here inside the root, so inside the root you have the complex number, so modulus here and taking square, so square and square root gets cancelled off. So what is modulus of alpha plus j beta? So modulus of alpha plus j beta is root of alpha square plus beta square. So now we have square of this, so modulus of alpha plus j beta whole square is alpha square plus beta square. Okay, squaring on both sides, so you'll get alpha square plus beta square. So in the place of this I am writing alpha square plus beta square. So already square and square root gets cancelled, so again you have modulus, so is equal to modulus of minus omega square mu epsilon plus j omega mu sigma. So is implies alpha square plus beta square is equal to minus, right, so root of, again sorry, root of, because when it is modulus you have to take root, so minus omega square mu epsilon whole square plus omega mu sigma whole square, omega mu sigma whole square. Okay, so alpha square plus beta square is equal to, so this will be take one omega mu. Okay, so omega mu is the constant we have, so omega mu is there here, it is there here also. Okay, so take omega mu outside this, so when you take omega mu outside the square root, what will be left over inside? So omega square came outside the root, so it will become omega. Mu square also came outside, it will be mu. So left over here is epsilon square only for the first term. I am talking about only first term. Okay, epsilon square only. Okay, so plus right, plus what is this value? So what, omega outside, mu also outside, so you will get left over with sigma square only. Omega mu, if you take common, sorry, here one omega is taken common here, so there will be another omega. Okay, so here omega square whole square is there. Okay, so omega square whole square is there, so it will be let me write one more step, then you'll understand clearly. Okay, so I don't want to confuse you. So root of, so minus omega square mu epsilon whole square can be written as omega to the power of 4 mu square epsilon square plus omega square mu square sigma square. Okay, so this can be written as root of omega square mu square if you take common, omega square mu square if you take common, so it will be omega square epsilon square plus sigma square. Okay, so omega square mu square, if you take outside the root, so it will become omega mu into root of sigma square plus omega square epsilon square. Okay, so this is the value of alpha square plus beta square. So this is, let this be equation number 3. So adding equation 1 and equation 3, so this is equation 1 and this is equation 3. So on the left hand side, what is left over? So alpha square plus beta square plus alpha square minus beta square is equal to so omega mu, so this is the positive term, so I am writing the positive term first, sigma square plus omega square epsilon square minus, right, so minus omega square mu epsilon. So minus beta square gets cancelled, so it will be 2 alpha square. So 2 alpha square is equal to omega mu into, if you send this omega epsilon this side, so if you take common, sigma by omega epsilon, if you take common, okay, so plus 1 if you have, so that means you are dividing with the omega square epsilon square. When you are dividing with omega square epsilon square, you have to multiply also with omega epsilon. Okay, so only for the first term. So only for the first time I'm dividing with omega square epsilon square. So if you divide with omega square epsilon square, so it will be sigma square by omega square epsilon square. So if you take square common, so sigma by omega square epsilon square by omega square epsilon square is 1. Okay, so this multiplied by omega epsilon minus omega square mu epsilon. So what is alpha square then? Alpha square is equal to omega square mu epsilon. Okay, so omega mu here and omega epsilon here, so omega into omega square mu epsilon into, okay, so by 2 I'm taking, so 2 if you send this side, it will become by 2 by sigma by omega epsilon whole square plus 1 minus 1. So this is whole multiplied. Okay, so alpha value, so the expression for alpha is, so root of this, right, so root of this, so root I'm taking mu omega outside this root, so omega into mu epsilon by 2 into 1 plus, okay, so root of course root of 1 plus sigma by omega epsilon whole square, okay, minus 1. So this is the formula which is in Nepper per meter. Okay, so very easy. So first of all, what you have to take, gamma is equal to alpha plus j beta, so root of j omega mu sigma plus j omega epsilon, so j alpha plus j beta whole square, squaring on both sides and equating real and imaginary parts, you will get equation 1 and equation 2, and taking modulus now. Okay, so taking modulus and doing some simplification, you will get alpha square plus beta square like this. Just add 1 and 3 equations. So 1 and 3 equations, if you add and take some common terms, so you'll get the equation like this. Okay, so this is very important formula, and this is the formula for attenuation constant in the case of EM wave. Okay, so let me take one more slide. I'll write equations 1 and 3 again. Okay, and I will solve for phase shift constant also. Okay, so I'm rewriting the equation 1. So we have gotten from equation 1, alpha square minus beta square is minus omega square mu epsilon, right? This is equation 1, and we require equation 3 also. So alpha square plus beta square is equal to omega mu into root of sigma square plus omega square epsilon square. This is what we have got for equation number 3, right? So just subtract equation 1 or equation 3 minus equation 1. Okay, so alpha square plus beta square, equation 3, minus alpha square minus beta square is equal to omega mu into root of sigma square plus omega square epsilon square, right, minus of minus. So minus of minus becomes plus here. Okay, so omega square mu epsilon. So alpha square and minus alpha square gets cancelled, so beta square minus of minus beta square is 2 beta square. So 2 beta square is equal to omega mu into, same as previous case, sigma by omega epsilon if you take common, plus 1, so it is multiplied by omega epsilon plus omega square mu epsilon. Okay, so 2 beta square is equal to omega square mu epsilon. If you take common, it will be root of sigma by omega epsilon whole square plus 1 plus 1. Okay, so beta square is equal to omega square into mu e by epsilon into root of 1 plus sigma by omega epsilon whole square plus 1. So beta is equal to, so take this omega square, so we'll have under root of this, right? So under root of this term, so under root of omega square is omega, so I'm writing omega outside and all remaining under root I'm writing. So mu epsilon by 2 into root of 1 plus sigma by omega epsilon, okay, omega epsilon whole square plus 1. Okay, so this is the formula for beta. Very simple, just subtract those two, you'll get beta, add those two, you'll get alpha. So this is in radians per meter, radians per meter. Okay, so very simple to remember the formula. So if you have plus sign, right, so this plus sign, this is the only difference between the formulas for alpha and beta. So if you have a plus sign here, it will be the formula for beta. If you have a minus sign here, it will be the formula for alpha. Remaining all terms are same, right? So these are the formulas for attenuation constant alpha, phase shift constant beta, and propagation constant gamma in terms of medium parameters. Okay, so this is the concept here. Okay.